Hello everyone at CIT 2020. On behalf of my colleagues and I, it is my pleasure and honor to show you the visual presentation of our paper, Design Techniques of FTTH-GPON Networks for Segmentation and Data Traffic Relief. Due to the actual circumstances, we're not able to make our presentation in person. However, we have at our reach developed technological tools that can connect our world virtually seamlessly, tumbling the barrier of the physical distance. Okay, so let's begin. At present, the technological progress in the telecommunications field is advancing with significant leaps. The average day for many individuals in their personal and professional lives require the use of technological tools for communication and information. Moreover, for these tools to be more effective, they depend on faster and reliable interchange of data frames. In response, Ecuador's Telecommunications Control and Regulation Agency has issued permits to many small ISPs nationwide to satisfy increased demand. However, many of these ISPs deploy their fiber to the home networks with designs focusing solely on revenue rather than quality of service. Or even worse, proceeding any method whatsoever, meaning they don't have any design at all. For these types of ISPs, their primary goal is to add more subscribers in the short term with minimal capital investment. Due to the absence of quality of service design, this model jeopardizes the availability and the speed of the service. Over time, because the data traffic increases with growth of subscribers and associated bandwidth. So we're going to talk about the theory of FTTH-GPON networks. So let's start with the architecture. The most used type of architecture is point to multipoint, like you see on the graphic, using a tree topology, and within the network, passive optic elements that doesn't need electrical source to help distribute data frames to its subscribers, like you see here in the graphic. Methodology, sizing of the FTTH-GPON core equipment. So we divided, in the paper, we divided this process in two. First for the OLET, ONT, and the second one for the ODN, that is the optical distribution network. So let's start for the first one. And let's see, what's the methodology consists on? First one, we're going to calculate the OLET splitting level. Second one, the OLET PON ports, number of PON ports, which is very important. Third, OLET quality of service parameters. Fourth, OLET units, brand and model. Fifth, OLET PON port zones. Sixth, ONT quality of service parameters. And finally, ONT brand and model. Okay, now for the ODN sizing. First of all, we're going to calculate the drop network. Second, we're going to calculate the feeder network. Third, the distribution network. Fourth, the feeder capacity. Fifth, the distribution capacity. And sixth, the architecture ODN. Okay, now we're going to check out the results. So let's go right here. Results calculation of the FTTH-GPON equipment. So let's start the results by the OLT and the ONT. Okay, now, first we calculated the optimal level of division of the OLT-PON. The GPON optical line terminal equipment can be configured in 3 splitting levels, 1 to 32, 1 to 64, and 1 to 128. Each port, meaning that each port can provide service to 32, 64, and 128 subscribers. This process is where most ISAPs, in the absence of quality of service criteria, choose to provide service to more subscribers with a single port without paying attention to bandwidth and subscribers growth. Now, as you can see, we're going to calculate the splitting level verification. So let's start. The bandwidth projected on our previous article, like we mentioned in the paper with a case study that is mentioned here, we projected that each subscriber will need 28.60 megabits per second here by 2023. It's not even far. So we have to do this splitting level verification. As you can see here, we're going to try the splitting level of 1 to 128 subscribers. With these equations, we can see that with this splitting level, we can only provide 1953 megabits per second for each subscriber, which is it does not comply because we need 2860 megabits per second. Let's get to the other one, splitting level verification of 1 to 64. With these equations, as you can see on the screen, we can have 39.06 megabits per second, almost 40 megabits per second for each subscribers. So this splitting level, it complies. Now, the second thing that we have to do, now that we have established that this splitting level is 1 to 64, now we have to calculate the number of PON ports with the equation shown on the screen. The population projected on our previous article that you guys, I definitely recommend that you guys read that article because it's the foundation of this article. The population projected for 2023 for the case study is almost 40,000 subscribers for FTTH-GPON networks. With the splitting level of 1 to 64, it means that we'll need 612 ports. The ODN architecture will have 2 splitting levels of 1 to 8, which sums 1 to 64 in total. The first splitting level is located at the splitting and splicing closure, right here. And the second splitting level is located at the network access point, or called NAP, right here. So you have the ODN architecture. Okay, now finally, we're going to the conclusions. Number 1, the determination of the technical specifications of the core equipment of the FTTH-GPON network has to comply with adequate sizing for the handling and growth of data traffic, with calculations with real and reliable data from accredited sources. We use the data of our previous case study of our article, and that information was taken from accredited sources. And if you're able to read our article, you will find out that it's true. Determining the make and model of the OLT requires meeting all technical specifications for current and future data traffic management, rather than selecting by the number of PON ports and slots, which is a common error in most designs. Most designers choose the number of PON ports and slots on OLT rather than focusing on quality of service parameters and splitting levels options. So please take this in mind. For our third conclusion, the identification and segmentation of data traffic in the OLT and ODN is of vital importance to solve in a timely and efficient manner problems such as congestion, collision, and packet loss. Thank you for your attention and all of your members that are looking at this presentation. And hopefully, if you have any questions, we can answer them. And thank you for your time, and I hope you have a good life. Thank you again, and thank you for the CIT 2020 and all of the people involved in them.